So I'm going to give a brief overview of OpenMP. It's an open source multi-processing library for C, C++, and Fortran if you so desire. So why? Just about everybody sitting in this room now has had some sort of experience with C++, but primarily serial operation. And so while that's great and gets the job done, a lot of your code can be sped up by multi-threading. And so why OpenMP? It's on the CPU, so you don't have to learn Cuda or OpenGL, as much as some people might like that. It is a bear to learn. So this is incredibly easy to use because it requires very little actual changes in your code. It's also cross-platform. It runs on Linux, Windows, OS X. There's a few others that probably no one really cares about. So for what applications is this helpful? If you want to just get up and running, array initialization, doing reductions, so sums or differences, and matrix arithmetic are all sped up incredibly by multiprocessing. So matrix initialization. Say you just want an array of random variables between 0 and 10. 0 and 9. If you want a million of those, and you're doing it sequentially, it takes upwards of about 2 seconds, I believe. However, if you run it in parallel, and the only change in this is that one line, which I believe was implemented in Prognos, or C++ 11, I believe. You add that and compile it with OpenMP. It takes a fraction of that time. So reductions, you're adding up a sum of, say, for whatever reason you want to do the sine of the square root of a bunch of numbers. Don't know why you want to do that, but you want to do that. The longest part about this isn't actually the sum. It's the fact that you have to do the sine and square root in serial. But if you do it in parallel, not only does the sum speed up, but since you're running the complex arithmetic functions in parallel, the speed up is tremendous. And it goes the same thing with if you're going to do matrix operations, so say dot product. If you're doing this in serial, it's the same thing. You can, I forgot to remove one thing. Anyway, it does the same thing. You're going to have a tremendous speed up if you have any amount of data that's more than about, I'd say an array of about 1,000. Is where you're going to start to see that speed up as opposed to just about the same time. So going back to this, the same ideas, it's minimal additional code. As you saw in all of those, you're adding maybe 2-3 lines of additional code, and that's around the stuff that you already have for the most part. Some of the more advanced features take a little bit more thought, but if all you're trying to do is speed up a couple for loops, it's very little additional work. But why would you not use this always? The startup cost of threads is much higher than the work it takes. If, say, you have a for loop that's adding up 100 numbers, starting up all the additional threads actually takes a lot more time than actually adding up the numbers. So in those situations, if you know it's a small amount of numbers, it's not worth it. But for large workloads, especially if you're doing anything with financials, anything with big data, using a multi-processing platform or a library like this can be incredibly helpful. So thanks to Marty Goldschmidt for that. I'm a soldier and RCOS. Are there any questions?